Hello and welcome back. This time we're looking at some calculus and some differentiation. Let's have a read. Differentiate each of the following expressions with respect to x. Only use the product rule if it is the simplest method. So let's have a look at a few of these questions. So let's look at A. Now, with question A, let's try the product rule and also expanding these brackets and see which one's easier. So we've got 3x minus 2 in brackets and x cubed plus 4 in brackets. So first off, let's use the product rule and try this out. So if I say it's just y equals 3x minus 2 in brackets multiplied by x cubed plus 4 in brackets, I can see this as a function of x times another function of x. So u in this case is just going to be our first function of x, or just the first bit in the brackets, 3x minus 2. And v is going to be x cubed plus 4. So the product rule needs us to derive both of these. So let's work that out. Du dx equals 3, and dv dx will just be 3x squared. The constants, the negative 2 and the plus 4, they'll disappear when we derive. Now, the derivative of our original function, 3x minus 2 in brackets and x cubed plus 4 in brackets, that will be v times du dx plus u times dv dx. Now, you might have seen this written as u times dv dx plus v times du dx. The order isn't really that important because it's a plus, but in the future, if you have to do quotient rule, just writing the v times du dx is a useful thing because the quotient rule begins with this. But anyway, let's substitute and see what happens. So v, let's use brackets whenever we're substituting, always a useful tip. Du dx, that's our 3, plus u, that's 3x minus 2, keep that in brackets, and dv dx, 3x squared. The bracket's also really useful if there's any negative signs or minus signs in there. Just helps you keep track of them. So let's see what we can do here. We can expand the brackets and simplify it. So this will become 3x cubed plus 12. And I'll just put a square bracket around that first term just to remind myself I've expanded those first two brackets there. And then another square bracket around these on the right. So the first term will be 9x cubed minus 6x squared. And we can fairly comfortably just gather like terms. So we've got 12x cubed minus 6x squared plus 12. So that was it using the product rule. So the product rule, the main part is just here. Recognizing we've got a function of x times a function of x. Most often you'll see it as a bracket with x in it multiplied by another bracket of x in it. If you can recognize that, you should be able to apply the product rule. Now, let's look at an alternative method of solving this, where we can just expand the brackets first. So let's write that down again, 3x minus 2 in brackets times x cubed plus 4. So let's expand this. We'll get 3x to the power of 4, that's that one there, then 3x times 4, that'll be 12x minus 2x cubed minus 8. There's no like terms we can gather up, but I can just order it a little bit nicer so that the powers are in descending order. So 3x to the power of 4 minus 2x cubed plus 12x minus 8. Now if I said that this was y equals that, I can fairly comfortably just derive that. So dy dx is going to be 12x to the power of 3 minus 6x squared plus 12. Wow, well, I know which method I would prefer to use if I had to specifically work out this. I would expand it first and then derive it. It's a lot easier to do. But depending on how complex your functions are, the product rule might be better. Let's have a quick look at one more question. Let's look at question f. So for f, I can see I've got a function of x multiplied by another function of x. Let's try and expand this one instead of using the product rule and see what happens. So 4, open bracket, x squared minus 1, x squared plus 2 in our second bracket. So let's expand this. I might do the 4 times this first bracket first. So 4x squared minus 4. And we still need to multiply by x squared plus 2. So let's expand this. 4x to the power of 4 plus 8x squared minus 4x squared minus 8. So here we can see, yes, we can gather some like terms. We've got some x squareds there. So we'll have 4x to the power of 4 plus 4x squared minus 8. So if we said that this was y, we can work out the derivative dy dx. This will be 16x to the power of 3 plus 8x. That's it. We're done. Wow. So, depending on the complexity of the question you're doing, try expanding. But if it's more complex, the product rule is definitely the way to go. Alright, thanks for joining me, and I'll see you next time.